Okay, so we covered all this material about the inheritance, and we say just a quick review. We talked about the inheritance, and we say to avoid code or to avoid any redundancy and to reuse the same code, I use inheritance. And we talked about or we defined the superclass, the base class, parent class, all are the same. If we refer to this class, I mean, if I have a class, let's say person, okay, and I have student who inherits features from person, then this one is the super class or the basic class or the parent class, all right, and the derived class or subclass or child class, all are the same, all right? So don't get confused because these words are used interchangeably. It means sometimes they use superclass, base class, or parent class. All are the same meaning. Okay, inheritance. The definition: when derived class derive derive a subclass from original class, the derived class or the subclass child class will inherit all the attributes and methods from the original class, the superclass. So any attributes, any methods in the original class will be inherited by the subclass. But of course, considering the accessibility and the access specifiers that we'll talk about it later, and we talked about it already. So in the following example, class circle inherits the coordinate x. I think we are talking about this example. Yeah, this is the example. See, here we have the class point, which is defined as has x as you know, the point x and y. The point has two features or two attributes, x and y. All right, and of course we've created we call them methods to get the values of x and return the values of x. And if you remember, we called this as accessors and this one as a mutator. The name, the terminology is very important. Okay, you have to memorize this name or to remember these names. Why? Because the variables x and y are private. Okay, and this is part of the information hiding. Okay, information hiding, it means nobody from outside or no code from outside the class can access x directly or y directly. We can access them using public methods. So this is the public. And also we talked about the constructor. This is constructor. The constructor to initialize, usually we use it to initialize, but not necessarily to initialize. You can put any instructions in the construction and the constructor. Actually, it's the first function that is executed or executed when we define an object. So if I define point P1 in the main function, okay, of course, in this case, I have to put equal point of 5, 6. Why? Because in this case, the constructor will be called. All right, so when you define point P1, then you have to initialize this. Actually, when the program or when the compiler sees that we are defining an object or an instance, this is called instance, all right, or an object from the class point, it will go directly to the constructor and execute it. So regardless of the contents of the constructor, it will be the first function or method that will be called when we define a new instance from the class. Remember this always. All right, sorry, this is not a mutator because this is get also accessor. These are the mutator. Okay. All right. So we have other functions. Whatever functions you want to add, you can add them. But in general, one of the most important thing is the constructor. The constructor name should be of the same name of the point. Okay, of the class. So point capital letter start with the capital P, and this one also start with capital P, and without any return and any type. I don't put void or integer. Remember, in any function we use return type, right? Like here, integer, void, etc. The constructor should not have this type. Also, all right. Let's see the idea of inheritance. This example we discussed it. We consider a group of employee. We need to create classes for everyone. Every employee should have a class. If we are talking of regular classes without inheritance, but with inheritance, as you can see here, I should define class for this programmer, class for HR, and class for administrator. But with inheritance, I'll take all the common attributes like name, ID, and calculate salary. All right. Here also you can see name, ID, and calculate salary for the three, and put them in one superclass. And in addition to the, and of course, all the objects will inherit from that superclass. In addition, I can add any other methods or attributes I need. So this is the main idea. For example, this is, I'll define a superclass called personnel. All right, the attributes, name, ID, calculate salary. Then in programmer, HR, administrator, I added only one attribute or method if I need. Now, if you can see now, this is satisfies, or this satisfies the code reusability. Then I need to write the code only once here. For example, the calculate salary. Maybe I will write, for example, double salary, all right, and double, let's say, what else? Any other parts. Then I use the same code. Allowance, for example, here, allowance, etc. I use the same code. I write only once. I write the code only once, but I'll use it in every or in each derived class. So this is the idea. The other thing that I don't need to use the data or to avoid redundancy in data. I don't want to define the same thing more than once in different classes. So I defined one, and that's it, and we will avoid any redundancy. This example, of course, we took it and we implemented it, and yeah, now we talked about the point, but we didn't talk about the inheritance. Now in inheritance here, class circle point. Notice that here I didn't put anything, so that means it's private. And this is important when we will talk about the inheritance modes, okay? It means that the inheritance mode is private, but usually to avoid anything at the beginning, we use public or protected. Public is better now. All right, because public means I have access to all the public functions and attributes in the superclass. Here, without it, of course, I think we'll get error if we want to access it. But as we say, we need to specify the access mode based on the application at hand. So see here, I have public radius, which is the the circle. It has center, and the center is a point, actually has X and Y. So I'll inherit X and Y from the point, and I will add another attribute, which is the radius. All right, so the constructor itself, it has to include the three things, X, Y, and R. But here also, X and Y are not members of the circle, right? But they are members of point, so I'll pass them directly to the point. Okay. Again, although the constructor here needs three parameters, but actually X and Y do not belong to the circle. They belong to to the point. So I'll pass them directly to the constructor of the point, and I'll define or initialize the radius equal r. Now you can add any other functions or methods such as find area and whatever methods you want to add. Okay, this is the code all together. We put everything together. All right. Now using this colon in inheritance, when you put this colon, that means circle will inherit everything from the class point. The class circle inherits all the features and methods of the class point. The class circle could have more attributes and methods other than those available in the point, and circle is known as child class or subclass, and point is known as parent class or superclass. The constructor here again, as we said, when you construct the circle, you'll pass three parameters, but actually X and Y are not members of circle. They are member of point. So I'll pass them directly to the point. Okay, but R is a member of circle. Then I have to initialize it here in the constructor. All right. Subclass can have more functions. So I defined another function, another method here, which is find area, which is not is available only for circle and is not accessible or available for point. Okay, so this is the main function. We tried it, and this is what we got. Inheritance mode is very important, as we said. If you remember when we talked about this, I told you it's by default private. But there are some other modes which are public and protected. Okay, so this is what we call the inheritance modes. It's the mode in which we want to inherit the subclass such as public, private, or protected. The derived class doesn't inherit access to private data members always, regardless of the mode of the inheritance. Derived class can never access the private members of the class, just like here. Okay, yeah, here we have X and Y. These are private, so the derived class circle will never be able to access X and Y. Cannot access them. But you may ask me, then how we pass this? Yeah, we can access the private, as we discussed before. We can access the private attributes using public functions. So point is a public function, the constructor. All right. Okay. So the derived class doesn't inherit access to private data members or methods, of course. However, it does inherit full parent objects, which contains any private members which that class declares. All right, so although here I have in the point I have X and Y, and I defined defined a new class, this point, this circle. Okay, and I have here derived class. The derived class circle can never access X and Y, but it contains them. It can use them. It can. Here, when we talked about the circle, we said we have the circle, the center, which is X, Y. Okay. You cannot change them. You cannot say, for example, X equal 5 here in the class. All right, but this cannot be done. But you can access them through the mutator and the accessors. All right. So remember this. Although it has the features X and Y, but it cannot change them. All right. So in all cases, private member in the base class cannot be directly accessed in the derived class. All right. Now the inheritance modes, we have three modes. We have public, protected, and private. Public mode, the public members of the base class will become public in the private class, and the protected members of the base class will become protected in the derived class. See, actually, we have three levels. I don't know if I have. Let's read this, and I'll explain to you in the next slide. Protected mode, both public members and protected members of the base class will become protected, and private mode will never be, or the derived class can never access them. See, actually, I have three levels. I have public, I have protected, and I have private. Public can be accessed from anywhere outside the class, all right? Protected can be accessed only by the class itself and the friend. We will define something called friend function and friend classes, all right? And the derived class if it's public. Private cannot be accessed from anywhere outside the class. Now, based on the mode, if I have the mode public, then the public will remain public. The protected will be protected. I think I'll make it like table. All right. I repeat it here because it's very important. All right, so I have the type here, public, protected, and private. This is the access specifier. Now, if I define here the inheritance is public, then public will be public. Protected will be protected. Private will remain private. Okay? Now, if I change here, for example, the protected, if I change it to protected, I'll go from bottom up. Private will be private. Protected will be protected because it's protected. Okay. Public will be converted to protected. Okay, because I reduced the accessibility. In public, I gave accessibility to everything, but here I reduced the accessibility. Now, finally, if I define it as private, so private will be private, protected will be private, and as a result, of course, the public will be private. Okay, so remember this. This is an example of how the accessibility changed. If I have here class A, I have public X, protected Y, and private Z. Z will never be accessed by the derived classes at all, in all cases. Y is accessible only if in class C, okay, because it will be protected, and in class A also. All right, so can be accessed. Public here can be accessed in class A. It will be public. Okay, in class C, because the inheritance mode is protected, it will be changed to be protected, and in class D, because the inheritance mode is private, it will be private. The protected here, Y, although the access mode here is public, but it will never, it will not be changed to be public. It will remain protected. Okay. Here protected, also it will remain protected, and finally the private will remain private in all cases. Okay, this is please differentiate between two things, the modes and the types. Here we are talking about inheritance modes. Okay. Next, we will be having inheritance types. In inheritance types, this is an example that we've created in the previous lectures. You can see how you can create the data or the model of any applications using object-oriented programming. Like, for example, if you take the transportation, so we have 4 different types. We have railways, we have vehicles, we have ships, and we have planes. Okay, and in British they called aeroplanes. All right. So in the railway, of course, I don't know. We didn't continue on this. If you have different kind of railways, like cargo train or travel, I don't know. Okay, then we can have also another 2 in the hierarchy. In vehicles, we have cars, we have buses, we have trucks, right? In ships, we have travel and we have cargo. In airplane, of course, if you need, you can find or derived classes from the airplane, like not Boeing. Boeing will be instance. Like large ones, a small one, anything you can derive it. Now, if you can see, if I take this car, okay, then car will be having some features, okay, its own of its own. Or let's take the bus, for example, number of passengers. All right. Number of passengers is not applicable to truck because truck has different attributes. All right, but it will inherit from the vehicles, for example, the wheels. Right, and from transportation, maybe the fuel. Okay, so we will put the attributes and the methods here, okay, for everyone, and collect the similar ones and put it in the superclass. All right, and then we will reach to a superclass. This hierarchy, of course, the type of inheritance will be defined based on the application. So let's see how many types, or what are the types of the inheritance that we have. Single inheritance. Basic class, I have basic class and attributes, methods, and derived class, attributes, methods, and of course plus its own attributes and methods. All right. So in this case, I have the basic class. If I say I have a basic class called vehicle. Okay, and I derived a class called bus. Then the vehicle maybe has the number of wheels. Maybe it has the fuel. Okay, but the bus has new attributes. Also, will take the number of wheels, will take the fuel, but also it can add more attributes like the load. Okay, how many tons, or not bus doesn't have the load, has number of passengers. All right, like 18 or 24 or etc. All right, or of course it can have its own attributes and methods. All right, so I'll derive when we create a derived class from the basic class, it will inherit everything in the basic class and add some more. This is the way how to write it. Subclass, in this case, if I have the subclass is car or bus. Okay, access mode here, you have to select public or private or protected. Okay, then the basic class, we say the basic class was vehicle. All right, here you don't need to write the same code that in the basic class. You just write your own or the new class features, attributes, and methods. All right, this is an example. Don't get scared. It's not that difficult. So we will explain it with inheritance and without inheritance. So okay, before inheritance and with inheritance. Include IOStream. Now we have class A public. We have A, the constructor, and cout. Just it will do nothing just to write this is class A. All right, and we implement this. Class B public B. Of course, this is the constructor. Cout. This is class B. Now, when I declare cout declaration of class A, when I declare A here, it will go directly to A. Will go and search for what? I know you may not be able to answer me, but I'm sure you are thinking of the constructor. All right, it will execute the constructor. The constructor says cout, this is a class A, and that's it. Now, when I declare class B, it will go and search for class B. It finds class B, then it searches for what? The constructor of class B, which says this is class B. So when I execute this declaration of class A, so this is what I got, and this is what I got in class B. Notice that here I didn't use any inheritance. Now, what will be the difference in the second example? Also, class A public, the same thing, 100% here. Here, if you can see, this is the difference. Here I defined only class A, here class A and colon B. And again, the same constructors and everything. The only thing that I've done is adding B inheritance from A. Now, when I declare here A, class A, okay, it will go directly to class A and execute this, which is this is class A. That's it. This is what we got. Okay, but when I declare class B will go there. I'll change the color so we don't get confused. Okay, class B here will go to execute the constructor of class B, this one. But it noticed that this class B inherits something from class A. So it calls class A again. All right, so there will be two stages. The first stage to go to the class and try to execute the constructor. All right, but it finds that this class inherits from another class. All right, so it will call class A and it will go to the constructor of class A. So class A constructor will be executed. After it finishes, it comes to the constructor of class B. So that's why this is class A and this is class B. Okay, so in inheritance, usually execute the constructors from top to bottom. Okay, it means if this is only single inheritance. All right, in double inheritance, I'll show you another example with which execute the. Sorry, just let me plug the charger of my laptop. 1 second. All right, so this is a single inheritance example application on the car. All right, so I'll define the class car. All right, this is the basic class with the name of car. Okay, which includes nothing till now. I just included the constructor, which print this is a car class. class truck, I defined, or yeah, we defined another class called the truck, okay, derived from the car class. It will get everything from the car, but it also can add more features or attributes and methods. But here also, for simplicity, we did nothing. Only the constructor will print, see, this is a truck class derived from car class. All right. So now if I define the car class, car C1, it will go to search for the class. Okay. When it finds this class, it will go to the constructor. It will print, this is car class. That's it. Done. Everything is done. Now, when I define truck, it will go to the truck and finds that the truck is not a pure class or a single class. It inherits things from other classes, which is from the car. Then it goes to the car, implement, okay, the constructor, and after it finishes, it comes and continue with this. That's why when we declare the truck here, we got, this is a car class and this is a truck class. So here, if I declare an object from truck, okay, T, okay, T will go there to the truck and finds that truck is inheriting things from car. So it holds here and go to the car. Okay, in the car, it goes to the constructor, implemented, then it comes back to continue with the derived class. Okay, multiple inheritance. Here it's something it's very useful, of course, because you can inherit different attributes from different classes. Like, for example, let's talk about the vehicles. Okay, or transportation, better, transportation. Okay, all transportation has have in common, transportation media have fuel in common, like this fuel works with electrical power or diesel or whatever. All right, and also we have vehicles, which has, as we said, number of wheels. Okay, now if I declare here a derived class, let's say truck. Okay, truck will inherit, for example, the fuel type from the transportation media, and can inherit number of wheels from, of course, not only the attributes, the methods also. Okay, from the vehicles, so it can inherit from multiple classes. How to write this? Class, subclass name. Here we can write, for example, truck. Access mode, maybe you can select it as public. Okay, basic class 1, transportation. Okay, another access comma. Remember that we have comma here. Another access mode, maybe also public. I'll select like public. Okay, class 2, maybe vehicles. Okay, and of course, if you have more classes, you just put comma, access mode, and another class. So I can inherit, or the derived class can inherit different attributes and methods from different super classes. For example, this is the class A. Okay, I have class A public. Nothing. This is just to explain the idea. I have class A. The constructor will write only this is class A, A1, and I have class A2. Okay, This is the class A2. Now, class B will inherit from A1, comma A2. Of course, I didn't put the specifier here because it's private. I don't need to worry about it. Okay, and also I have the constructor of B, which is this is class B. Now, when I declare class B, let's see, I have here class A1. Okay, and I have here class A2. And I have a derived class, which is B. Okay, B will inherit from A and A1 and A2. Now, if we are talking about B, if I here only will print class A, A1. Okay, this will print class A2. This will print class B. Okay, if I declare now A1, A1, for example, in the main function, then it will find that I'm defining an instance of the class A1. It will go directly to A1. So what will be the output? The output will be class A1. If I define A2, okay, also I'll call the variable A2, it will go directly to A2 and execute the constructor, which is class A2. But if I declare here a variable B of type B, it will go to the B. All right, but before that, it will find that B inherits from two different classes. So it will go to the first class and execute class A1. After it finishes, it comes back here and finds it needs to go back to A2. Then it writes class A2. Then after it finishes, it comes to the constructor and prints class B. All right. That means it inherits from different classes. If I have another classes, the third classes, then it will go and execute the third classes as well. All right. This is the example also, the car that we talk about. Class, I have car. Okay. Nothing will do nothing till now. Of course, you can put whatever attribute, whatever method, but for simplicity to avoid any unnecessary details now, so we just put in the constructor this is a car class. Okay, class vehicle, public vehicle, see out, this is vehicle class. Now truck will inherit public car, public vehicle. All right, and also it has its own constructor, which is this is a truck class derived from car class. So if I define C1 as car, see, only this one. This is a car class. If I define V1 as a vehicle, then it will implement only the vehicle because vehicle doesn't inherit anything. So this is a vehicle class. But when I declare truck here, it will go to the class. It finds it inherits from car and from vehicle. So it will go first to the car, implement it, and go to the vehicle, implement it, and go back to. That's why I got three messages. This is a car class, this is a vehicle class, and this is a truck class. Okay. Now I'll stop here because I want to open the discussion with you. And we'll continue with multi-level inheritance in the next lecture. And I want you, we don't have much more in the types of inheritance. We'll start with the other parts of inheritance, like abstract classes and some other details. But now I want to open the discussion with you. If you have any questions, I want you to implement this code, please, or these programs, the examples that I've given to you here. I want you to implement them and see the result. Okay, they are not difficult. very easy, but I want you to implement them and see the result. And after that, we will continue with the rest of the class. I'll stop recording now, so to give you the opportunity to ask questions, and if you have anything, please feel free to ask.